For the first question of the multiple choice of the homework, it says, assuming independent assortment for all gene pairs, what is the probability that a cross between one parent, big A, big B, big C, and another parent whose genotype is big A, big B, and little c, will produce an offspring that has the genotype of big A, little b, and big C, little c. So to do this problem, you can look at the gene separately. You can consider each one first and then multiply their probabilities together. For example, let's look first at the A gene. You could draw a Punnett square for this one. And just fill it in as usual. And you were wondering, you were supposed to calculate the probability of getting this genotype in the offspring. So for the A gene, the probability of getting a heterozygote, or big A, little a, is 1, 2. 2 out of 4, or 1/2. So you can write that down on the side and then go on to calculating the probability of the next gene. So doing the same thing that we just did for the A gene, we do for the B gene. Draw a Punnett square as usual and label it with the parental genotypes. The probability of getting little b from a cross between these parents is 1 out of 4. So you can come over here and write 1 over 4 over there. Lastly, you do the C gene. Draw the Punnett square as usual. It doesn't matter which parent you put on the top or the side. And then for the C gene, the probability of getting big C, little c is 2 out of 4, or 1/2. So you remember from the law of independent assortment that these genes segregate independently from one another. So their probabilities are also considered independent of one another. So to get the probability of getting an offspring with this genotype, you take the probability for each one and multiply it together. So the probability of getting this genotype from these parents is 1 over 16.